Now we will do the winding resistance test. Let me just mention that usually this is the last test you will do because of many reasons. We'll talk about them later, but also because it's the longest test usually. How will we measure winding resistance on this transformer? First, we will measure the winding resistance on the secondary side, phase A. Then we will change the connections like this and measure phase B, and in the end like this in phase C. But we are starting with this. Why does this test take longer to execute? Simply because when you're generating a certain current on the winding is basically against that change. The inductance of the winding is not allowing that change to happen. It's resisting the change, and that's why we can raise the current slowly. So let us now, having connected between phases A and neutral, measure the winding of phase A of the secondary side. Here I have connected the input of the current and the output of the current. Let's say current is coming in here and leaving through here, and the voltage measurement. So having connected like this, let's move on to the STS to do the test. Let's do the winding resistance test. First, let me explain the connections on the STS. So what are we doing here? We are generating from the 6 amp output. Of course, 6 amp is the maximum here. You can generate any other current which is lower. And by the way, let me say that we also have another output through which we can generate up to 100 amp DC, but in this case we are using this output. And from 6 amp, from the source, we are sending it to the ammeter. Here, we measure this current with a very accurate ammeter because the accuracy is very high, 0.2%. And this wire goes to the secondary side of the transformer, to phase A. And in order to close the circuit from neutral, I close the circuit here. So once again, generating current, going to the ammeter, measuring current, sending the current to the transformer, and returning from the transformer to close the circuit here. And in the same points, neutral and phase A, because now I will measure the winding resistance of phase A, I'm also measuring the voltage drop. Because as we know, in order to measure resistance, I need to generate current and measure the voltage. So accurate measurement of the current, which I'm generating, measurement of the voltage drop, and the system STS automatically calculates the winding resistance. Now, I choose winding resistance in an automatic mode. I think, well, we've done some measurement, and the resistance, the nominal resistance, should be around 10 milliohms, so 0.0, let me say 11 maybe. This is not necessary to write, but if you know the value, it's good to write because then you will get an automatic pass or fail. And I will choose 5 amps to generate. I will generate 5 amps, and by the way, with 5 amps, the minimum resistance you can measure is 1 milliohm and the maximum is 7. If I were to change this to 1, you will see these numbers changing. So then we will generate, the minimum resistance would be 5 milliohm and the maximum 35 ohm. But as we said, let's generate 5. I choose once again the phase I'm measuring and I press start. What we are seeing right now is the current, which is raising, and the voltage, which I'm measuring. This can take between 1 or 2 minutes, because what we want is for the voltage drop to stabilize so that we can have an accurate measurement, because the winding, which we are measuring, has this characteristic of opposing the change. As soon as there is any change of current, it generates a certain voltage, so we want to have a stable voltage measurement to be able to say that we have measured the correct resistance. And we can already see that the resistance being measured, let it stabilize a little bit, is about right now 8 milliohms, but let it go to 5, which it did now, and let's see how will this finish. All right, we've measured the resistance. So the measured resistance is 9.9, very close to what I expected. The compensated resistance is 10. Compensated means that if you measured at 25, which is the temperature right now, what would have been the resistance, what would be the resistance measured at 40 degrees Celsius? It would be slightly higher. So this is how we measured the resistance of phase A. Now let me change the connections and measure the resistance of phase B. So having successfully measured 9.93 milliohms, and this is expected on the secondary side to have a low resistance because the current is higher. Now let's move on to phase B and measure phase B. How do we do that? We simply change the connections from phase A to phase B. The current will be running now through the secondary side and phase B of the secondary side, and it will measure the voltage drop. So let's move on. The scenario is the same. The current slowly rises because it cannot rise in a step function on a winding. So right now the STS is generating about 2 amps, and the measured resistance is very close to the measured resistance of phase B is very close to the resistance of phase A. And in about 1 minute or something like that, we'll have the result. All right, STS measured the resistance of phase B, and we can compare 9.9, 9.7. This is very close, but let's also measure phase C so that we can be sure. Let me move to the transformer and measure and change the connections to C. How do we do that? Once again, we just change the generation from now what it was phase B, phase C. So now we will generate current between phases C and the neutral, measure the voltage drop. Now let me do that. And now I press start. All right, phase C is measured. So we generated 4.937 amps. The voltage measured was 5.388 millivolts. It took us this much time, and we measured 9.6. Now let me do one thing. If we go here, we can see another. So 9701. What do we use this for? Since we mentioned that the maximum difference between the windings can be 2%, in this case we actually have 5% or 4% between phases A and C, which means that this transformer might not be functioning as well, might not be functioning correctly. And just before I finish, let me tell you that if you are not sure how to connect, you can always press the question mark button and see how the connections should be done. So for phase A, for phase B, and for phase C. So we measure now the secondary side, and we've seen that the resistance of the secondary side is very small, 10 milliohms. Why is it small? As mentioned before, because on the secondary side the voltage is lower, but the current is higher because the power needs to be the same or very close to the power on the primary side. But on the primary side we have 18.5 kilovolts. Here we have 400 volts. So proportionally, here we can have, not necessarily proportionally, but generally the resistance of the primary side is higher. In this case, I'm expecting about 40 ohm, 10 milliohm, 40 ohm. For that reason, we will also change the testing current. It will not be 5 amps, it will be lower, but this would be my first measurement. Because this is a delta, first I'm measuring between phases A and B, then after that I will be measuring between phases B and C, and in the end I will be measuring between phases A and C. But now we start, now we start with phases A, and B. And now let me move to the STS in order to do the test. All right, so let's see how we measure now the winding resistance of the primary side. It's basically the same like secondary. I'm just going to separate them so that I have results later separated. I want to have them like that. You don't need to have them like that. So I'm choosing high voltage side here, which is a D. And I expect approximately the resistance of about 40, but let me put a little bit more. Let me put 42 ohms. 42 ohms. I cannot measure it with 5 amps because the maximum resistance I can measure with 5 amps is 7 ohms. So I'm going to change this to 0.7. Oh, sorry. 0.7. And that allows me to measure resistances up to 50 ohms. Let me just repeat and show you that you could also use the output 400 amps, but in this case I prefer to use the 6 amp output. I'm connecting I'm connected between phases A and B, and I press start. Okay. So we finished with phase A. Let's move on now to phase B. We got an expected number as a result. Let me change the connections. A and B. I change to B and C. Let me just mention one thing while I'm doing this. There is an accessory called STS. I mentioned it before. If you use STS only with one set of connections, you can do all the tests. But it wouldn't make sense in this webinar because then you wouldn't be able to learn as much as you are learning right now. So let's do the measurement of winding resistance between phases B and C on the primary side. All right, BC measured. Let's do CA. Once again, moving here. C, A. Now we are measuring the winding resistance between phases A and C. Let me now move to STS. Okay, I changed the connections to phase C, and now let's do phase C, or to be more accurate, let's do measurement of winding resistance between phases A and C. All right, just to tell you, what you see here is the discharge process. We are obliged by the law basically to do that so that if somebody touches two phases, it doesn't get burned or electrocuted. We see the results: 40.7, 41.0, 41.1. Let's go here and check the results in a different way. So 101, 99, 99. Basically, the biggest difference is less than 2, which means that the primary side winding is okay. And once again, if you were not sure how to connect, press the question mark button and you see here how the connections should be executed. Phase A, phase B, phase C, or once again, if you have STS, you would connect only once and all the changes would be switched with the switch box. So let me now just go and save the results, and the results are saved. That's it from us when it comes to winding resistance.